Assalamu alaikum everyone. I'm back with another lesson. Today we are going to study carboxylic acids. Carboxylic acids are also known as organic acids. Okay. So first thing first, their general formula is CnH2n plus 1 COOH, and the functional group is COOH. If I just open up its structure, so carbon is basically double bonded to an oxygen and then single bonded to the other oxygen. It looks something like this. Okay, so carbon is double bonded to one oxygen and single bonded to another oxygen. This looks like this, and all the carboxylic acids end with the suffix oic acid. Methanoic acid, propanoic acid, ethanoic acid, butanoic acid. So let's write down the first four carboxylic acids. Okay. Now the thing is, the functional group of carbon itself has, even the functional group of carboxylic acid has one carbon in it, which means that if I put N is equal to 1, the resultant molecule will already have two carbon atoms. Okay, so for that we need to put N is equal to 0 so that we can make the first member of the carboxylic acid group, because the first member can only have one carbon atom. Okay, in case of carboxylic acid. Now what would happen if I put N is equal to 0, and carbon would be 0 here, H, 2 zeros are 0, 0 plus 1 H. So molecular formula would be H COOH. Okay, this is the carboxylic acid with one carbon atom, and that carbon atom actually already existed in the functional group of the carboxylic acid. So we always remember that we start with N is equal to 0. So it would be called methanoic acid. It would be called methanoic acid, and the structure would look something like this: H C double bond O H. Okay, if N is equal to 1, then the formula would be C1, H, 2 ones are 2 plus 1 3, so CH3 COOH. It would be called ethanoic acid. Remember, whenever you're counting the carbon atoms of an acid, do not forget the carbon atom that is attached to the functional group. There are two carbon atoms, 1 and 2. So how would you write this? CH3 C double bond O or OH. Okay. Now if N is equal to 2, then it would be C2H5 COOH, and the name would be propanoic acid, and the structure would be C H H H H H H H H C double bond O H. Okay, so this would be propanoic acid. If you see, it is lagging by 1. It will always lag by 1. If they ask you to make a carboxylic acid with 5 carbon atoms, so you would put N is equal to 4, and the rest of the carbon atom, the remaining carbon atom, would actually come from the functional group itself. Repeating again, if they ask you to make a carboxylic acid with 5 carbon atoms, okay, then you would put N is equal to 4 in the general formula. When you put N is equal to 4 plus this one will become 5 carbon atoms. Okay, so remember that. Now let's talk about the reactions of carboxylic acids. But even before that, I need to tell you that let's say if I take ethanoic acid, CH3 COOH, when carboxylic acid dissociate into water, they form these ions, CH3COO -1 plus H plus 1. All the carboxylic acids are going to release one hydrogen ion, and the remaining molecule and the remaining structure will have a -1 charge. Let's say I am making this propanoic acid. it will split into hydrogen ion and the remaining molecule. This hydrogen ion is released in water and the remaining ion remains as it is. It will always have a -1 charge, C2H5 COO -1. Okay, if make anyone C4H9 COOH, even that would have the same template. So C4H9 COO -1 plus H plus 1. Okay, so remember that they actually act as acids, and that's why they're called acid. And acids are substances which release hydrogen ions in water. That's what they're doing. I'm just trying to tell you that when they release hydrogen ion in water, the remaining molecule also have -1 charge. Okay, and you need to know one thing. And that is when carboxylic acid loses a hydrogen. When carboxylic acid loses a hydrogen, carboxylic acid minus hydrogen, the name changes in the following way. Oic acid becomes O8. When carboxylic acid loses hydrogen, oic acid becomes O8. Like in this case, this is what? This is ethanoic acid. Ethanoic acid has 2 carbon atoms. It is ethanoic acid. When it loses hydrogen, it becomes ethanoate. This is propanoic acid. It becomes propanoate. In this case, this ethanoate ion. This is propanoate ion. This is 5 carbon atoms. Then pentanoate ion. Pentanoic acid became pentanoate ion. Now let's talk about their reactions. They react exactly like acids. Other than the combustion reactions that they give, they will also give carbon dioxide and water. So I'm not writing it down because we have done it many times. Okay. So first reaction of acids were that when acids react with metals, they form salt and hydrogen. When acids react with metals, we know it forms salt and hydrogen. We have discussed it in the acid and base chapter in quite detail. So if you missed that video, go back to that video and check out this concept. So let's see if I'm taking an ethanoic acid CH3COOH, I'm reacting it with a metal Na. So how does the salt forms? Metal hits the negative ion of the acid. The negative ion here is CH3COO -1 and metal is Na +1. So the salt that will be formed will be CH3COO Na. It will take the position of hydrogen and hydrogen gas will be formed. There is 1 hydrogen, 2 hydrogens, 3, 1, 3. Okay, this would be half a mole of hydrogen. Okay. Now let's say the other property was when acids react with metal oxides. They used to form salt and water. Okay, take any metal oxide and take any carboxylic acid. I'm taking ethanoic acid again and I'm taking calcium oxide. How does the salt form? Metal hits the negative ion of the acid. So acid ion is CH3COO -1, calcium is +2. This 2 goes here, 1 goes here. It becomes CH3COO taken power 2 calcium. Okay, and these are 2 molecules and the hydrogen is also water is released. Sorry, there are 2 CH3COOs. There will be 2 CH3COOs. As in that hydrogen became 2. Hydrogen is already 2. You should also know how to name them. This is ethanoate. So you will call it sodium ethanoate. And you will call this calcium ethanoate. Okay. It follows the other properties as well, that when acids react with metal hydroxide, they form salt and water. Let's take propanoic acid, C2H5COOH, reacts with magnesium hydroxide. So metal will hit the negative ion of the acid. Magnesium has a +2 charge. So C2H5 will also be taken power 2 Mg plus water, or multiplied by 2. And then you'll have to multiply this by 2 as well to balance this equation. Again, if acid reacts with metal carbonate, they form salt, carbon dioxide and water. They follow the same reaction as well. let's take ethanoic acid again. By the way, this would be magnesium. This would be magnesium. This propanoic acid ka hydrogen removal. So this would be propanoate. Propanoate. Okay. C2H5 COOH reacting with let's say sodium carbonate Na2CO3. So metal will hit the negative ion of the acid. Sodium has +1 charge. C2H5 COO has -1 charge. So there won't be any brackets here. Simply sodium will be attached over here. Okay, and there will be carbon dioxide formed and water will also be formed. Okay. So this is how acids react. Now, most important reaction of acids is of carboxylic acid is the esterification. So let's talk about esterification. But before we do that, I need to tell you another concept. Like I told you that when carboxylic acids lose hydrogen, they become OH ions from oic acid. Similarly, if you remove one hydrogen from alkanes, they become alkyls. For example, methane becomes methyl. Ethane is C2H6. You remove its hydrogen C2H5, it becomes ethyl. Okay, propane becomes propyl. Butane becomes butyl. So C3H7 is propane. C3H8 is propane. You remove its hydrogen, make it C3H7, it will become propyl. This is propyl. This is ethyl. Okay, and this is methyl. Okay, just remember that. Now we are going to make a compound that is called ester, and the process of making esters is called esterification. Now, how is an ester formed? You take an alcohol. In fact, let me just rephrase it. You take a carboxylic acid. And you react it with an alcohol. Ester and water is formed. How exactly? Let's discuss that. I'm taking a carboxylic acid, that is CH3COOH. I've taken ethanoic acid, and I'm taking methanol, CH3OH. What would happen? What happens is that we know that acids are known for releasing hydrogen ions. So hydrogen from the acid and hydroxide from the alcohol will react to form water. And this CH3 will get attached to the carboxylic acid part. So this CH3, the remaining part of the alcohol will go to the remaining part of the acid. So it would be CH3. It will become CH3COO, CH3. Okay. Repeating again. When ethanoic acid is reacting with methanol, so H from carboxylic acid and OH from alcohol, from in this case methanol, reacts to form water, and the remaining alcohol group gets attached to the remaining acid group. Okay, the remaining part of the alcohol group, okay, it gets attached in place of hydrogen. I'll name it later. But first, this is methyl. This part is methyl, and this is the hydrogen removed from ethanoic acid. This would be ethanoid. This is methyl, and this is ethanoid. Okay. Now let's take another acid. I'm taking another acid, C2H5COOH. That is propanoic acid. Reacting it with ethanol. Ethanol is C2H5OH. Again, H from carboxylic acid and OH from from alcohol will react to form water, and the remaining alcohol part gets attached to the remaining acid part. So you'll have C2H5 COO C2H5. The C2H5 will take the place of hydrogen here. Okay, this is an ester. This is an ester. This part is propyl. Like I told, this part is ethyl. Sorry, like I told you here. When you remove one hydrogen from ethane, it becomes ethyl. So this part is ethyl, and this is propanoate. Because propanoic acid has lost the hydrogen. This part is propanoate. Okay, let's just do another example. Let's take the example of butanoic acid, that is C4H9COOH, and I'm reacting it with propanol C3H7OH. Again, hydrogen from acid and OH from alcohol will react together to form water, and the remaining alcohol part will attach itself in place of hydrogen. You'll have C4H9COO C3H7. Okay, so this is an ester. Now this part is propyl and this part is butanoate. This part is butanoate. So how would you name it? Okay, if I just go by sequence, now this is ethanoate because ethanoic acid has lost an hydrogen. This is ethanoate. Now it should be ethanoate methyl, right? But the convention states that you write the name of alcohol part first and the carboxylic part later. So you would name it methyl, which is this part, ethanoate. This ester would be called methyl ethanoate. This ester would be called ethyl. This part first. Ethyl, 1 to 3 carbon atom carboxylic acid, propanoate. Okay, you'll name this. This side first. This is propyl. And this part is 5 carbon atoms. In fact, this is not butanoic acid. This is pentanoic acid. Okay, this is pentanoic acid. 5 carbon atoms are here. So when butanoic acid loses the hydrogen, it forms a butanoate ion. So this part is butanoate. So propyl pentanoate. Sorry, when pentanoic acid loses a hydrogen ion, it will form a pentanoate ion. So this is pentanoate, 5 carbon atoms carboxylic acid that has lost a hydrogen. So you will say propyl pentanoate. Now let's draw the structures of these esters. Okay, this is fun. CH3, C double bond O, CH3. Methyl ethanoate. What about ethyl propanoate? C2H5, you will draw C2H5. 1, 2, 3, 4, 5. C2H5. Okay. This COO is of carboxylic acid. So obviously, a carbon is double bonded to one oxygen and single bonded to other oxygen. And C2H5. C2H5. This is ethyl propanoate. Okay, the alcohol group, always remember the alcohol group comes after carboxylic acid. Okay, so this part is named first and this part is named after. Okay, propyl pentanoate, C4H9. There you go, C4H9. I'm not writing hydrogen now. C4H9, C double bond O. So you'll have to show this C double bond O here. Then C3 and H7. 1, 2, 3, 4, 5, 6, and 7. Okay, now what kind of questions can they ask you? They can directly ask you to draw the structure of, let's say they can ask you to draw the structure of ethyl propanoate. They're asking you to draw the structure of ethyl propanoate. So you should not attempt to draw the structure of this particular ester without writing its molecular formula. So you know that ethyl actually is named first but comes after. So ethyl is actually C2H5. It is one hydrogen removed from ethane, and propanoate is one hydrogen removed from propanoic acid. So that would be C2H5COO. So you write down the molecular formula for this, and then you can draw the structure conveniently. C2H5C double bond O part. This part, by the way, is called the ester linkage. It's called the ester linkage. This is the functional group of ester, C double O. This is the functional group of ester. You're not going to study the reactions of ester, but you should know that this is the functional group of ester. Okay. So that's how you will make it. I think you have done enough practice for it. Let's say if they ask you to write the molecular formula of pentyl butanoate. So you know the name of the first component is actually alcohol that comes after. So pentyl is one hydrogen removed from pentane. Pentane is C5H12. Pentyl would be C5H11. And butanoate is one hydrogen removed from butanoic acid. And butanoic acid is C3H7COOH. So it would be C3H7COO. Okay. Now this reaction can also go back. The same reaction that is forming ester, if you reverse this reaction in this direction, this is called hydrolysis. You are using water to break ester into respective alcohol and carboxylic acid. So by just looking at it, if you break methyl ethanoate, you should know that methyl will break down into methanol, and ethanoate will break down into ethanoic acid. Ethyl will break down into ethanol. Propanoate will break down into propanoic acid. If you go back, if you use water to break it, okay, and you cannot use only water, you use concentrated H2SO4 as well as heat. That are the conditions for the hydrolysis reactions. Okay, concentrated H2SO4 and heat. The reverse of esterification is hydrolysis. Lysis means breakdown. Hydro meaning water. You are breaking something with the help of water. Okay, so that was all about esters. You should know another thing, that esters are used in food flavorings. And ester is used in making perfumes because they have a sweet smell. They are used in making perfumes because they have a sweet smell. Now let's get down to solving some of the past paper questions related to carboxylic acids. Question number 1. Ethanol was reacted with propanoic acid in the presence of concentrated sulfuric acid. Don't get confused with these formula. They looked a bit different, but they are actually the same. Did you know that's a 2 carbon atom? Alcohol is ethanol. So when ethanol is C2H5OH, it's reacting with propanoic acid, which is C2H5COOH. And as a result, the ester that will be formed would be, this portion will get attached at the end of this. You will have C2H5COO, C2H5. So this statement about the organic product of this reaction is correct. It has the formula C5H10O2. Let's count the number of carbon atoms. 2, 3, 5. 5 carbon atoms, 5 and 5, 10 hydrogens. Hydrogens are 10 and oxygens are 2. So it has the formula C5H10O2. That's correct. Okay. Which statement about ethanoic acid is correct? Ethanoic acid can be made by the addition of steam to ethene? No. Ethanol can be made by this method. Propanoic acid can react with ethanoic acid to produce an ester? No. An acid has to react with an alcohol to produce an ester. The formula of ethanoic acid is CH3COOH. That's true. The 2 carbon atoms, carboxylic acid. 2 esters have the same molecular formula, C3H6O2. So C double bond OO. This is the center point of the ester. Okay, there are 3 carbon atoms, so there is possibility that there is 1 hydrogen here and C2H5 over here. 3 carbon atoms, and there is the possibility that there is 1 CH3 here and 1 CH3 here. So there are 3 carbon atoms. So this the name of this one is ethyl methanoate. Ethyl methanoate. So this, and the other one's name is ethyl. No, this is methyl. Methyl ethanoate. Methyl ethanoate. So it would be 1 and 3. They have the, so there can be certain esters which have the same molecular formula but have different structures. Okay. So you can say they are isomers of each other. Which statement is correct? Carboxylic acid contains this group. No, it contains this group. OH is there. It is not the answer. Ethanoic acid will react and fizz when copper is added. Okay. Ethanol will decolorize. No, it will not. Structure of ethyl ethanoate is ethyl. No, it is methyl. It is methyl, and this is methanol. So answer would be B. When acids react with metals, hydrogen is released. That is where the fizz is coming from. Okay. Acha, this is from macromolecules. Let's move on. The diagram shows the structure of an organic acid. Which acid it is? 3 carbon atom acid, which is called propanoic acid. Which row is correct? This is propanoic acid. Does it react with aqueous sodium carbonate to produce carbon dioxide? Yes, it will. All the acids react with metal carbonates to produce carbon dioxide. So it will be propanoic acid and a yes. Okay. 7. Which reactions will occur with this compound? This is a double bond and then there is carboxylic acid. Bromine water will decolorize because there is a double bond here. It will react with an alcohol to form an ester. Yes, it will, because acid, this is the acid part, it will react with alcohol to form an ester. It will react with sodium metal. Yes, it will react with sodium metal because the acids react with metals to form carbon dioxide. The answer would be 1, 2 and 3. So, ethanol reacts with ethanoic acid and ethyl ethanoate is formed. What is the formula of the ester formed when methanol reacts with butanoic acid? So methanol will form methyl, okay, and butanoic acid will be butanoate. Methyl butanoate. So this methyl comes after but named first. Where is methyl? There is methyl, and that is butanoate. 3 and 4 carbon atoms. So answer is D. Okay, don't get confused by these structures. They are pretty much the same. If you just place O over here and you write it like this, it's the same thing. Okay, what are the starting materials for making this compound? This is what? This is 1, 2, 3. The part that comes after the carboxylic acid, COO part, the part that comes after the COO, that is the alcohol part. So there are 3 carbon atoms, so obviously it is going to be a propanol. It is made from propanol, and these are 4 carbon atoms of the acid, so it is going to be made from butanoic acid. Okay, so propanol and butanoic acid. If you break them down, they will break down into propanol and butanoic acid. How do you break them down? You do hydrolysis in the presence of conc H2SO4. Okay. The solubility of the carboxylic acid decreases with the size of carboxylic acid, which means the greater the size of carboxylic acid, lower will be its solubility. So, which is least soluble? The biggest one will be the least soluble, that is butanoic acid. So, what are these 3 processes? Compound X was converted into ethene. Okay, alkenes can be prepared by cracking, so it can be A or B. Ethene then became ethanol, so it can be made into ethanol by adding water, which is hydration, and ethanol got converted into ethanoic acid, which is oxidation. So answer would be A. Okay, shown below are properties of compound X. Compound X reacts with metal carbonate to produce carbon dioxide. It has to be an acid. It reacts with ethanol to produce a sweet smelling liquid, which is ester. So it is obviously a carboxylic acid, so it is ethanoic acid. Which carboxylic acid will be formed? Which ester will be formed using the carboxylic acid and alcohol shown below? So at the end of this acid there will be, so this OH will be removed, this H will be removed, and at the end of this C3H 7 will be attached. C3H, 7 will be attached. C3H, 7 will be attached. You just need to find that out. After carboxylic acid, there will be C3H7. This is C4, so this cannot be the answer. After carboxylic acid, this is again C4. This cannot be the answer. Okay, there should be 3 carbon atoms attached after carboxylic acid. If you see after this COO, it is inverted, so don't get confused. After COO, there are 3 carbon atoms attached here. It can be the answer. And if you check this, after carboxylic acid, 3 carbon atoms are attached here. Now you will have to look at the acid part. The acid had 5 carbon atoms. 1, 2, 3, 4, 5 carbon atoms. So between them, this one has 1, 2, 3, 4, 5 carbon atoms, and this one has 1, 2, 3, 4, 5 carbon atoms. So which one would it be? So the answer would be look at the attachment. The CH3 is attached to the carbon atom that is attached to the carboxylic acid group. Okay, so which would it be? It would be this, because the CH3 group is attached to the carbon atom, it is attached to the carboxylic acid group. The answer would be D. For which molecules empirical and molecular formula are the same? Just write their empirical formula down and their molecular formula down. For example, this is CH2O2, its molecular formula. This is C2H4O2. This is C3H6O2. This is C4H8O2. Okay. Now, these are their molecular formulas. What would be the empirical formulas? Empirical formulas are the expressions that are used to represent a compound in the simplest whole number ratio. Now, CH2O2 cannot be further reduced. It will remain the same. We'll have to find out molecules whose empirical and molecular formula are the same. You can reduce this to CH2O. You can reduce this to CH2O. You can reduce this to CH2O. So 2, 3 and 4 have the same molecular and empirical formulas. Okay. Now I think you have done most of the type of the questions. So that would be all from this chapter. Inshallah, I'll get back to you with another chapter, with another video, and that would be on the macromolecule chapter, which is again a very interesting and a very important chapter. Okay. Until then, see you later. Allah Hafiz.